Hi. Today we're going to talk about how you get user input and what forms of inputs there are that we can use and what data types we're going to use to get our users' inputs. The simplest form of user input is obviously a string and a number. By string I mean text. So what is a string? A string is basically a space or a container for our text. So everything we type in will be stored as a string. If you want to store a number, we're going to use the integer variable, because the integer is the simplest form of a variable that there is for a number. So to define a string and an integer in C++, it's really easy. It's the same way we would do it in C#. To do that, let's first define our variable for our number, for example, to show you some form of user input, hence why I have two files here prepared. This one will contain a simple calculator, which will be used to explain how to make a calculator itself, and then user input so that we can do stuff with it, obviously. So let's first get some user inputs going. So first off, let's get some variables. So let's make an integer variable called num for a number, and a string variable for text, because why not? So let's first ask the user to write some text. This is the thing about C++. In C++, defining how to get full length strings, it's a bit more complicated than that. So to get the full line of a text we type in, I'm going to explain as I'm writing it. So first, let's output to our terminal or to our command line that we want to get some input from the user. So to do that, we're going to write out, what do we want? Type in a text, for example. And you might have noticed I haven't used the end line thing I used in my original one. So to show you that, let me go into my C drive, to my code folder, and you might remember the hello-world.cpp file. You might remember I have the end line thing here. Well, you don't even have to use it, you can just write it out like this. I used it because it's the first one that's used all the time. It's not required, it will work the same way. And it will also make it easier for us. The end line basically will move the cursor down for us, which is neat, but you know, we don't need that. So let's space this out a little. But this way, when it's written out this way, it's essentially like console write, where it just writes and puts the cursor behind it. But if we put the end line thing, it will be like console write line, where it will write out the line and move our cursor down by one. Basically on the next line, essentially. So next, what we want to do, we want to get the thing that the user has typed in, so the entire line, the entire thing, you know. So to do that, we want to do get, and I believe it was line, and then we do what form we want to do. So we want to obviously get the input, so cin for input, and then what variable we want to store it as, which in our case is text, so we're going to do text. And we're going to end it off with a semicolon, obviously. So what this line will do, it will get everything that's on the line as a form of input and store it into text, into our variable, string variable called text. So that's neat, so we got our text input. But we want to make sure that the user sees what we have typed out, don't we? To see if it did type it out, we're going to do a cout once again. But see out, there we go. And we want to write out that, I don't know, our text is, and to differentiate our text from that, I'm going to use dashes, because why not? And then to load in, right after this string, our variable, we're going to use the two left pointing arrows, because we want to get that variable's contents, its data, and put it as part of our text. So you do it like this, And what do you do now? You type in just text, and then you do the other two to complete the line essentially. You could have left it as it is, but I'm going to make it look a bit prettier. We're going to do dash and then dot to separate it a bit. So what we will see if we decide to run it now, like it will work at this stage. Actually, let me show you if it will work. It's better to show us an example. So let's compile the user input. Again, the same logic applies. G++, the CPV file, -o as the output, and then user input.exe. And now we decide to run user input.exe. It will ask us to type in our text. Notice that our cursor hasn't moved on the line next. That's because it doesn't have the end line thing in it. I know, let's type in this is a sample text, and look at that. Our text is, and remember this is just a variable, so it will actually write out for us that this is a sample text, which is what we wanted, obviously. So now we've got our text being printed out if the user types it in. That's cool. But what about numbers? Well, to get numbers, it's actually even simpler, believe it or not. So we're going to use our num variable now. So now we're going to ask the user to type in a number. I'm actually going to steal this line right here so I don't have to rewrite it. But I'm going to do one more thing. I'm going to, how did it print it out? Did it? Yeah, it was automatically. So to move it to the next line and prevent it from doing weird stuff, I could either add a end line thing at the back here, but what I like doing is I usually just add in a backslash and a and. This will indent it by one line below, therefore I don't have to worry about it at all, and I can have a nice clean form of a output, which is what I want. To get input in C++, it's really easy. Instead of cout, you will type in cin as input. And then you would do it, whoops, wrong direction. You have to move them to the right side because we want to store the input as a form of variable. And now what we want to do is we want to store the, instead of text, I want to change this to number. Because we want to get the user to type in a number, obviously. And we want to store the number he types in as a variable. To do that, we type in just num, because num is our integer and that's what we want to store it as. So we can call it, you know, make it a bit easier for ourselves. And what we do next? Well, next we do, we're gonna output what the number is that he has written, obviously. So to do that, we type in cout, not count, but cout. Oops, wrong thing. So cout, wrong arrows again. So you need to remember the arrows, but that's nothing that complicated. I'm going to copy this thing, you know, it's easier for ourselves. And we're going to do our number is, and here we're going to change this to num, because num is our variable. Again, if I highlight this, you'll notice that our integer variable is num, and we want to print out the num variable. And that's pretty much it. So now if I decide to compile this code, as you can see, it compiled without any issues. So if I decide to run this, it will ask us for a text. So this is a test. You can see it wrote out that our text is, this is a test, so it still works. And it asks us for a number, let's do 5, why not? And it says that our number is 5. So that is user input. I guess that in the next one we're going to cover how to make a calculator, because this is getting a bit long and I want to keep it. Actually, you know what, now let's do the calculator right away. Why not? We're trying to get everything covered, aren't we? So let's do the calculator right now. Like, what else do we have to lose? So to create a calculator, let me first clear out the output of a command. So that's our user input, obviously. So that's user input pretty much explained in detail. So now we're going to go into the meat and create our calculator. I'm going to make a Alright, so how would you go about creating a full-fledged calculator? So first off, we're going to have 3 variables defined, 3 of those. So to define 3 variables, we can do it like this. So we're going to create a x, y, and sum, because we're gonna sum those 2 numbers up. We're going to make a really simple one. It's going to do just addition, because I don't want to waste your time with pretty much boring stuff. Next, we're going to use what we've learned. We want to output a text to let the user know, hey, I need you to type in some text. Well, cout, and then we want to do this, and the text we want to do is type in the first, we'll type in a number, why not a number, type in a number, boom. And then we're going to take this as a form of input and store its value into our x variable. Then we can copy this set of code and we're going to type in another number. We're going to start as our y variable, and then we're going to add them together. So we're going to do sum equals x plus y, and next we're going to let the user know that the calculation has been done. So we're going to type in cout, again like that, and we're going to type in the sum is, and then we want to add the variable sum to it because we want to print out the sum. So this should print out the sum of those numbers, obviously. I'm just going to change this to, we have our simple calc, so simple calc -o simple calc.exe. Let's compile it. You can see it worked. Let's execute it. So it asks us to type in a number. So to do that, let's type in, I don't know, 2. Type in another number. Let's do 6. The sum is 8, which is correct. So 2 plus 6 is 8. But you can also do subtraction, multiplication, and division. To do that, we're going to add sub for subtraction, more for multiplication, and div for division. And we're just going to copy this about, 4 times. And we're going to do, we want to do sub for subtraction, which we'll use the minus sign for. Let me space these out a little, this looks a bit ugly, there we go. Next will be multiplication, so to do multiplication we need to start as mul. And if we want to do division, we just do div, and we have to use the / as division. And now we're going to copy this, and again about 4 times. 1, 2, 3, 4, there we go. And we're going to do the sub is, and we do sub, then the mul for multiplication, and then we do mul, and then the division, so we're going to do div, and we're going to do div here as well. And one thing you'll notice that as soon as we decide to compile this and run it, let's type in 2 and 6, you'll see that it does everything correctly, but the text is a bit jumbled up. That's because we did not make it so that it will So it says that the sum is, so the sum doesn't even need to have that, but in order to stay safe with everything, I'm going to just indent these one line so it moves to another line no matter what, therefore fixing our output and make it look a bit more clean. So let me recompile this, and let's run it again, and let's do the same numbers, so 2 and 6, and there it is. And you can see that division is wrong, isn't it? Division says that it's 0. Well, that's because of our data type. To fix this, we're going to have to use something called a float. A float is essentially like a number with the decimal point, which is what we want in our calculations, obviously. So just change it to a float and it should work. So let's recompile this, and let's run it. So we're going to do 2 and 6 once again, and you'll notice that it's fixed now, that it says the number as it should. And that's it. There's nothing else to it, it's as simple as that. And now get yourself a full-fledged calculator, a simple one, not really full-fledged, but it's a simple one. So now we know user input, we know output, we know how to do calculations. There's still a bunch of other things we want to do with this, but I guess we could cover conditions next and such, because you know, it's nothing like that complicated. I do actually want to go over the data types first, because there are a bunch of different data types, there aren't just that, but I actually did mention data types, didn't I? I did cover those actually. I managed to cover all the important ones that we're going to use. So basically, the only thing left for us to do is, I guess, cover conditions. And then after we're done covering conditions, we're going to cover switches, loops, and arrays. And then and then references and pointers. And then also functions and such, but you know, that's a topic for another day.